So let's say that we have a potential. So let's make the potential, this is x, and we'll have a potential V, which is, say, here its value is V naught, and so we'll have V naught all the way to minus infinity. Here it'll still be V naught, and then for some value it becomes 0, so it drops down, and then for some value here it again comes up to V naught and goes on to positive infinity. And let's say we have a bound state, so the energy is there, and it's not the ground state, but it's the first excited state. And we want to get a sense of the eigenfunction, and then we want to change this potential. So let's draw the eigenfunction. So this is x, and we want, terrible drawing on this side, but it doesn't matter, psi 2 of x. And let's take this point, put it there, and that point there. And so the function, well, let's look at the Schrodinger equation. Right? The Schrodinger equation reads second derivative of the eigenfunction. In this case, it's d2 of psi 2 in x squared equals 2m over h bar squared v minus e psi 2 of x. And so in this region, right in here, we have, this is 0, so we have a negative constant here because the energy is positive, it's above 0. And so the bending has to be towards the x-axis. So if we decide that the psi 2 of x is positive here, then we will have some positive bending in here. And we have to respect the symmetry. We have to reflect the symmetry. Our eigenfunction has to reflect the symmetry of the potential, so we have to have an odd function, so we have to come through 0, always bending toward the axis. And that's true below, so the function is negative, so we have to bend upwards. And that looks fairly symmetric. And then outside of this region, right, the signs, v jumps up to v naught, and the same thing is true over here. And so we have a difference, v naught minus c, that's positive, and so we have to choose the exponential decay solution, and so out there we'll do something like that. We'll do the same thing there, roughly, and that looks fairly symmetric. Now let's change the potential. Let's say that we have a potential which is a little different. Here is x, and we'll have, this is v naught. We'll come to, this will continue as it was over there. Then we'll come down to 0. And then here again we'll be at v naught, 2x equals infinity. But then we won't go to 0 there. Halfway through the well, we'll do something like that. So this value here is greater than 0. Here it's 0, so we're doing what we had there. Now we want to look at the same eigenfunction. So we're sort of assuming that there's an energy there and that it's E2. And so we're going to plot the psi 2 of x. So let's see if I have enough space here. That's x. psi 2 of x, and we'll put that there, this is there, and that is the midpoint. So everything is the same on this side, so we come over here like this, and the Schrodinger equation tells us that the bending is exactly the same on this side, so the functions here look the same. We'll come down through 0, and so here it's exponential decay, and we'll look like that again. Here we'll come down through 0, but then the Schrodinger equation tells us that as soon as we cross this point, it says bend in such a way that v minus e is now, this difference, and that's smaller than it was here. Right? So we still have bending towards the x-axis, but we're going to bend less, and therefore bending less means that it's going to take us a while before we come back down. So basically the amplitude has to be greater on this side. So it's going to be something like that. That looks like a larger amplitude. On that side, we're going to start to come down, and so something like that. And then we'll have the same solution that we had here. It's exponential decay, but it's exponential decay starting from some point that's higher up, so it's going to take us. All right, so the amplitude for the particle on this side, right, the probability density when we square this is greater on this side because the difference here is smaller, the bending is less. In some sense, we can think of the momentum as being smaller here, so the particle sort of hangs out to the right of the well midpoint.